Hello everyone, my name is Aliza Zia and I'm from class 12-7, and today I'm going to be talking about derivatives, or as in Indonesia we call it Turunan. We're going to look on how derivatives can help us set the best price for concert tickets, math meets concerts, economics, and also your favorite K-pop group. Section number 1, or as I call it, setting up the real-life problems. Imagine if you're like a huge promoter for concerts as big as like New Jeans, Stray Kids, and many more. And as the promoter, you would want to make the most money possible from ticket sales. But here's the catch. If the ticket price is too high, people wouldn't buy. But then, if the ticket price is too low, sure everyone buys, but then your revenue sucks. And so the big question is, at what price should we sell tickets to make the maximum revenue? And that's where math, specifically derivatives, is actually useful. We're going to be moving on to section number 2, which I'm going to call modeling ticket sales with a function. So let's say the number of the tickets sold depends on the price. Where more expensive, fewer people would buy. And that relationship is modeled like this. QP equals to 5,000 and then 20p. And here's what everything means. QP means number of the tickets sold, and P means the price, and which in this context we're talking about 1,000 rupiah. And 5,000 means the maximum number of fans that might buy if the price is super cheap. And 20p means how quickly customers drop off as the price goes up. And to simplify, if ticket prices get too high, people usually run. We're going to be moving on to section number 3, which I'm going to call it the revenue function. I also call it the money part. And so what the promoter really cares about is revenue, and revenue is literally just price multiplied by quantity. And so from then on, we plug QP into the formula. So this is how I write it, but then I'm going to be expanding it so that it looks kind of nicer. So basically what this function tells you is how much money you make depending on what price you choose. Moving on to section number 4, and there's a lot of questions on like why do we need derivatives and just a lot of whys. And so I'm going to be doing a small detour. Why are we even doing derivatives? And so derivatives help us find where a function is increasing, where it's decreasing, and most importantly, where it peaks. A turning point, and that turning point might be a maximum or a minimum. And in this case, we're hunting for the maximum revenue. So then we're going to be moving on to section number 5, which we take the derivative slowly. And let's do derivative step by step. We're differentiating RP equals to 5,000p minus 20p squared. So then on, the derivative rules. And so the derivative rules that you'll use is that derivative of AP is just A, and derivative of P squared is 2P. And so RP equals to 5,000 minus by 40P. And that's the rate of change of revenue depending on the price. Moving on to section number 6 is that I'm going to be calling how to find the critical point. We set the derivative equal to 0 because that's where the slope levels out, the peak revenue. And so 5,000 minus 40p equals to 0. And how to solve it is that 40p equals to 5,000 and the p equals to 125. So the best price, or the price that gives maximum revenue, is 125,000 rupiah. For section number 7 is checking with a second derivative or an extra explanation so that we can check if this point is actually a maximum, not a minimum or a random weird point. And because the results are negative, means the graph is shaped like a frown or a downward parabola, like that. I'm gonna be doing it one more time, like that. And it's like a sad face, right? But a downward parabola means the point is definitely a maximum. So for section number 8, we have interpretation, or how to make it relatable. And a lot of people might ask, what does this mean for the concert promoter in real life? Well, I would answer by, if they price the ticket too low, they sell a lot but make little revenue. And if they price it too high, hardly anyone buys it. But then at 125k, that's a sweet spot. The perfect balance of price and the number of fans will actually pay. And so that is how derivatives help us with a lot of things such as concerts, online shopping, and many more else. But then in this activity, we're trying to find out when concert ticket sales bring in the highest possible money. By checking how the revenue changed as more tickets were sold, we found the exact point where the earnings stopped increasing and started going down again. And that point represents the moment when the concert makes the most profit. And after calculating it and checking the graph in GeoGebra, both methods show the same result, where there's a specific numbers of tickets that gives the maximum revenue, and selling more or fewer than that amount will make the total money go down. And this proves how helpful this kind of analysis is for real situations like planning concerts, setting prices, and making sure an event earns as much as possible. Thank you!